Now that we have the ability to follow a series of waypoints, Chapter 12 seeks to answer the question, how do we produce those waypoints? Now there's a whole host of path planning techniques. So Chapter 12 really only scratches the surface of the possible capabilities, but it does provide a couple of representative techniques. So in this lecture, we're going to review the architecture that we've been developing throughout the semester, and we're going to discuss planning at a high level and show a simple example. In the following lectures, we're going to first give an example of Voronoi graph planning. This is a common discrete planning technique, and we can use common graph search techniques to solve it. Then we'll jump into rapidly exploring random trees, which is a common example of a common sample-based technique. We'll show how we can look at RRT with 3D terrain or consider 3D terrain. And then we'll discuss optimal variance, where we can make local modifications to RRT to make it optimal as the number of samples goes to infinity. So let's go ahead and get started. Here's the architecture that we're so familiar with now at this point. And you'll see that here at Chapter 12, we've hit the final level of that architecture. Now really we've been doing a series of planning and control the entire semester. Right, so at the low level, we have the autopilot, which is really a low-level planner or controller. And the autopilot takes into account the airspeed, altitude, heading, those commands to produce the control to execute on the actual aircraft. And it'll actually send out those servo commands to the unmanned aircraft. Now the autopilot needs to be run at a fast speed, 100 hertz plus, right? So it needs to be running really fast, taking into account the airspeed, but also taking into account the full state of the system and trying to adjust the control to make sure that it's following those commands. We also discussed path following, which is really a mid-level planner. And this path following produces those airspeeds, altitudes, and heading commands while taking in the path definition. And we discussed two different capabilities. We discussed being able to follow straight line paths and also to be able to follow orbits. And on top of that, we have the path manager, which takes in the series of waypoints and decides which path segment we're going to be following. But this mid-level planner or controller needs to be running fast enough that it's able to calculate the desired vector to be followed. And from that vector, we produce that airspeed, altitude, and heading commands. And so you might consider this mid-level control running at 1 to 10 hertz, where you have the manager itself, or you have maybe, we could call this mid-level management, operating at an order of magnitude higher. Maybe we're operating at 0.1 to 1 hertz. And these are just rough orders of magnitude, but the idea is that as we move up, the frequency that we need to be updating our plans or the commands that we're giving to the lower levels, the frequency is much, much lower, right? And then in Chapter 12, we're going to be discussing what could be considered high-level path planning. So this could be a high-level planner. And this could be run at 0.1 to 1 hertz or maybe even on demand as needed, right? And so in this case, we're going to be producing the waypoints to be followed. And if you're considering the full trajectory of the aircraft, these waypoints could be hundreds or thousands of meters in separation. And so it's going to take a while to actually execute all of those waypoints. And in this book, we're going to stop right there, but that's not the end of planning, right? We could come up here higher where we have mission level planning. Or we're doing collaboration with other aircraft or trying to accomplish particular objectives, right? And that's going to give us that destination. It's going to tell us about the obstacles. We're going to be ingesting the map information. So we have higher levels of planning, and we can continue to go up. But the thing we need to notice is that at the autopilot level, we're running really fast, right? But we're only considering the current state of the aircraft. With path following, we're still running fairly fast, but we're still only considering the current state of the aircraft and not destination, but the type of maneuvers we want to be doing to get to a straight line or an orbit, right? So we're still very, very local, but now we've extended our horizon to say, hey, this will take us to some desired maneuver. Then as we jump up into the high-level path planner, now we're doing this at a much slower rate, perhaps only even on demand, but our horizons are very large. We could be planning over thousands of kilometers, right, in terms of deciding where we're going. Okay, so it's important to note that we have different rate and we also have different lengths of plans. And there's a whole host of different types of approaches. We'll be talking more about deliberative approaches. So based on global world knowledge, we're going to make a plan of action, and this is often known as plan, then act. Right, so it requires a good map of terrain, a good knowledge of your environment. It can be computationally intense for dynamic environments. If you have a lot of things changing, you can only be deliberative over so long, or so long of a horizon. And like we mentioned before, it's going to be executed at a much slower rate. Reactive planning is more of this idea of sense than act. And this is on the other end of the spectrum. It's based on what the sensors detect and an immediate horizon, right? It can respond to dynamic environments, things that pop up, but it's usually not used for the entire mission. So these are two ends of a spectrum of planning. And in reality, modern planners use both reactive and deliberative components. Reactive because they can react really quickly to changes in the environment, and deliberative is because we really want to make sure we're getting to or doing what we want to do. Excellent. So let's take a look at one such deliberative planner that we're going to be developing. Over here we have our raw simulation with the aircraft over here in gray, magnified by 100 so we can actually see it in the environment, with an environment modeled as a bunch of buildings that the aircraft needs to navigate around. So some higher level planner, me pressing the go to goal position, gives the aircraft a position to follow, and then we can plan a path. And once it's planned, the plan will come out as this green line that we're going to be following, a series of waypoints for the aircraft. And if I could actually start it, there we go. And we'll see that we're going to be utilizing that full planning stack. So using straight lines and circular arcs, back to another straight line. The aircraft, we've given it a goal point. It made a plan using the path planner. And you'll see that this planner actually isn't optimal, but it was okay. Then that planner gives a series of waypoints. Those series of waypoints are interpreted as straight lines and circular fillets to be able to navigate from start to end. So there you have it. We have a full demonstration of that architecture that we've been talking about throughout the entire course.